Hello students, welcome to ePhysics. Students, in this video we will be discussing about the continuous distribution of charge. What is the continuous distribution of charge? Students, continuous distribution of charge means the distribution of charge in any body uniformly. If the charge is distributed uniformly in any body, then that is we consider as the uniform distribution, that is, or we can also write it as or read it as continuous distribution. Now in the continuous distribution of charge, students, we used to discuss it in three different ways. The first way is linear distribution, the linear distribution of charge. The second way, if the charge is distributed uniformly in any surface. And in the third way, if the charge is distributed uniformly in any given volume. Okay, now slowly we will be discussing all these three topics. So let's move it with the first topic, that is the linear distribution of charge. In the linear distribution of charge, we call it as the linear charge density. Linear charge density. In the linear charge density, students, we will be discussing or we will be considering any linear body. It may be a straight line, it may be a curved body, it may be a circular body, or anything, but it should be linear. Linear means we will be talking about the length of the body only. For simplicity, let us consider we have a body whose length is L, in which the charge Q is uniformly distributed. Okay, charge Q is uniformly distributed. Now in this case, student, the linear charge density is denoted with lambda. So lambda will be equal to Q, that is the uniform charge, that is the charge which is distributed uniformly in length L. So the linear charge density lambda is equals to Q upon L. Now unit of the linear charge density, that is lambda, will be equal to the unit of charge is coulomb, the unit of length is meter. The coulomb per meter, we can write it as coulomb per meter or simply coulomb meter inverse. Clear with this? Now let us consider an example. Let us consider an example of it. Let the charge Q is uniformly distributed. Okay, is uniformly distributed over a circular ring of radius capital R. Okay, in this case lambda will be equal to, now charge Q is distributed, so charge Q divided by length. Now we will be considering a circular ring. This is the circular ring whose radius is R, and the charge is distributed in the length of the circle. Length of the circle means simply we will be considering the circumference of the circle. Okay, the circumference of the circle, which is equals to L. So L will be equal to circumference, that is 2 pi, capital R is the radius, so capital R over here. So the solution of the question that we have considered in the example will be Q upon 2 pi R. Now let's move to the second one, that is the surface charge density. Now here, students, in surface charge density, let us consider a surface whose surface area is capital A, in which the charge is uniformly distributed. Okay, the charge Q, let us consider Q amount of charge is uniformly distributed over the surface whose area is A. In this case, the surface charge density, which is denoted by sigma, will be equal to Q charge, which is uniformly distributed upon area of the surface. Clear with this? Now the unit of this surface charge density will be equal to, that is the unit of charge is again coulomb, the unit of area is meter square. So it is coulomb per meter square, or also we can write it as coulomb meter to the power minus 2. Clear with this? Now let us consider an example of it. Again, let us consider we have a sphere whose radius is r. Okay, let us consider whose radius is capital R, and in this surface of this sphere the q amount of charge is uniformly distributed. Q amount of charge is uniformly distributed. In this case, the surface charge density will be equal to q upon the surface area of the sphere. Surface area of the sphere. Now what is the surface area of the sphere? It is equals to 4 pi r square. So the surface charge density in this case will be equal to q upon 4 pi r square. So this is it. Now let's move to the third topic of the video. Now students, in the third topic, that is the volume charge density, we will be considering any body. Let us consider here, for simplicity, let us consider we have a sphere again, a sphere, okay, in whose volume the charge q is uniformly distributed. Charge q is uniformly distributed. In this case, the volume charge density, which is denoted by rho, will be equal to charge q, which is uniformly distributed in any volume, so it will be divided by volume. Okay, hence the volume charge density will have the unit, that is the unit will be equal to, the unit of charge is again coulomb, the unit of volume is meter cube, so we can write it as coulomb per meter cube, or we can simply write it as coulomb meter to the power minus 3. Okay, all these three forms of writing the unit is correct. Whichever you feel comfortable in writing, you can take it as your comfortability. You can take any of these options. Now let us consider an example that charge q is uniformly distributed over any volume. Let us consider in any spherical body whose radius is r. Okay, radius is equals to capital R. If we consider this a spherical body, okay, according to the question, a spherical body whose radius is r, in which the charge q is uniformly distributed, then the volume charge density, that is rho, will be equal to q with q amount of charge which is equally or uniformly distributed in the volume of the spherical body, divided by the volume of the sphere, that is equals to q upon the volume of the sphere. We all know it as 4 by 3 pi multiplied by square cube of radius, that is radius in this case is capital R, so 4 by 3 pi capital R cube is the volume charge density. Okay, so this is how we have discussed about the uniform charge density or the continuous distribution of the charge. In this video we have discussed the three different distribution of charges. In the first case we have taken the one-dimensional surface, that is the one-dimensional topic, that is the linear one, then the two-dimensional surface, and the three-dimensional, that is the volumetric charge distribution. So I hope you understood the video very nicely. Thank you very much for watching.